Hey geometry students, welcome to lesson 10.2, areas of trapezoids, rhombi, and kites. Hope you're doing well today. Let's jump right into the lesson here. So we talked about in 10.1 that the area of a rectangle is base times height. Again, everything's going to come back to that. All of these we can compare to rectangles to derive the formula. So on this part, on the trapezoid, I'd say just watch this for a moment. Don't write anything down, but the red stuff here as I initially start, just watch what I'm doing here. If we found the length of what we call a mid-segment, so if we take this, it's the average of these two bases. And if we took this little triangle right here and we put it up here, and we took this little triangle right here and we put it up here, what would we get? We'd get a rectangle right here. That would be base times height. So whatever the length of this is times whatever the height of the trapezoid is would give you the formula for any trapezoid. So what is the length of that mid-segment? It's the average of the two bases. It's b1 plus b2 over 2. So at this point, I'm going to erase what I just did there, and I can't see my eraser. That's kind of weird. There it is. We got rid of all of that. And so now I would draw this in on your picture. So if we take the height of the trapezoid perpendicular to the two bases, call this b1, call this b2 down here. We're going to take the average of the bases, so b1 plus b2 divided by 2, and multiply that by the height. That is going to be your formula for any trapezoid. So that, I would write that somewhere on your notes. That's the average of the bases right there. The average of the bases is right there. So that's your area formula for a trapezoid. And then again, why don't I do this in green? I'll mix up the colors here. Don't write what I'm doing in green here, but if you look at a rhombus and you compare a rhombus to a rectangle, this is not a great picture, but assume that's a perfectly drawn rectangle around that. It touches all 4 points right there. And if you looked at each one of these little triangles, this and this would be the same, this and this would be the same, this and this, this and this. So if we took base times height, it'd be the length of this diagonal times the length of this diagonal, but it's only half of that because the rhombus itself only takes up half of that area. Same thing applies to a kite. So again, don't draw what I'm doing here in green. If we look at the length of the diagonal, and the length of the diagonal, that would be the base and the height of this rectangle. This is the same as this is this, this is this, and this is this. So we've got 1/2 base times height, in a sense, becomes 1/2 d1 times d2 if I say d1 and d2 are the diagonals. So let me get rid of that here. And we'll draw in, this is really strange. I can't see where, that's better. Go away. There we go. So you're going to have, for both of these formulas, the area will be 1/2 times diagonal 1 times diagonal 2. So for this one, and remember with a trapezoid, these parts are parallel. For a rhombus, all sides are congruent, so you could draw that on your picture. For a kite, 2 pairs of consecutive sides are congruent. So this is congruent to this, this is congruent to that. So from there, this is going to be what we'll call, wow, let's try that again, D1 right there. So from there to there is D1, and then from here to here is D2. So the area of this is 1/2 D1 times D2. And the same thing works for kites. So from here to here, I'll call that D1. And from here to here, I'll call that D2. And same formula. So 1/2 D1 times D2. If you wanted to write D1 times D2 over 2, that works just as well. So let's check out example 1, broken into 3 parts here. We're given this information. KS is 8, so why don't I label that as I say it. ES is 6, right there. A kite, hopefully something you remember from our quadrilaterals chapter. A kite has perpendicular diagonals, so I'm going to put that in there. That may be useful in particular problems dealing with these types of things. TS is 16. So on this one, another thing that the diagonals of a kite does, one of the diagonals does bisect the other diagonal. So they don't both bisect each other, but this would be congruent to this right here. So if that's 6, this is also going to be 6. given that information, I now have everything I need to replace the letters in my formula with the numbers that they're equivalent to. So again, I would strongly encourage you to write out the formulas in general and then plug in what you know to find out what you don't. So this is going to be 1/2, and then D1, 8 plus 16 would be the length of this whole diagonal, and then this one would be 6 plus 6. So we've got 1/2 times 24 times 12. Half of 24 is 12. 12 times 12 is 144. Units are not given on this one, so you could leave it blank, or you could write units squared after that if you wanted to, just to get in that good habit. I think it's a good habit to be in. So then on part B, this one, all the information is directly given to you already. It doesn't really matter if I call this B1 and B2 or vice versa. So we've got the height, we've got base 1, we've got base 2. We need to find the length of the midsegment, which is found by finding the average of those two and then multiply that by the height. So we have on this, again, write that general formula out with the letters first and then plug in the numbers from there. I think that's the best way to go. You've got 32 plus 18 divided by 2 times 11.5. I could have written dot or parentheses, works just as well here. So this would be 50 over 2, which becomes 25. So you have 25 times 11.5 on this one. If you plug that into a calculator, or if you're really good at the mental math there, you'd get 287.5. And units are given here. This is a very big trapezoid, kilometers squared. So 287.5 kilometers squared. And then finally on part C, for example 1 here, you've got that RB is 21, MB is 40. For a rhombus, anytime you have a rhombus, the diagonals bisect each other. Both diagonals bisect one another. So this would also be 40. Let me try to make that look a little prettier there. That's a bad looking 4. There we go, 40. And this is 21 there. So from there, take your formula, write it out, plug in what you know to find what you don't. So we've got area is 1/2 D1 times D2. D1 could be written as 40 plus 40. D2 could be written as 21 plus 21. So you'd have 1/2 of 80 times 42. And if you work that out, you end up getting 1680. So 1,680 feet squared on this one. Area, anytime you're dealing with area, units squared, you're multiplying feet times feet, kilometers times kilometers, and so on. So that's example 1, and the formulas, let's look at 2 and 3 here, and we'll be all set with this lesson. So rhombus QRST has an area of 500 meters squared. I'm going to write that inside on this one to remind myself of that. If QS is twice as long as RT, find QS and RT. So this Q to S is twice as much or 2 times as long as what we have from R to T. So if I called RT X, what would this be? It'd be twice that, 2x. And so if I take my formula, write it out in general, 1/2 D1 times D2 for a rhombus, plug in what I know. This time I know the area is 500, so I'm going to replace A with 500. And I don't know D1 and D2, but I do know that I can call them X and 2x. So again, the order here, commutative property of multiplication, addition. With addition, multiplication, it doesn't matter what order you do things in. So I could do 2x first or x first. I'll put 2x here, and I'll put x here. If I multiply 1/2 times 2, that's going to be just 1. So I just have x times x from there. So I'd have 500 equals x squared. From there, you could take the square root of both sides. And then if you're one of my geometry students especially, we did a chapter earlier on or we did our trig chapter. We had to do simplified radical form quite a bit with that. So if I do that here, I take 500. Some of you feel most comfortable doing it this way. So you could break this down into something like 10 and 50, and then you'd have 2 and 5, and this would be 5 and 10. I'm circling the prime factors, the ones that I can't break down any farther. And so now I have the prime factorization of 500. That means 500 could be rewritten as, and I'm going to put square root here and square root here, and then write all my factors out. 2 times 2 times 5 times 5 times 5. Look for any pairs. You've got a pair of 2s, so that could come out, square root of 2 times 2 as a single 2. And then you've got a pair of 5s here, so you could take out a 5. Square root of 5 times 5 is just 5, and then you have a 5 left on the inside there. So this could be, in simplified radical form, exact value 10 root 5 would be what the square root of 5 is equivalent to. And then x squared, square root of that, that's going to cancel. So you've got x is equal to 10 root 5. The other way, the perfect square method, you could use on this one. I'll do that in orange here. This is my preferred way. If you get good at it, it's faster. So if you do the square root of 500 and notice the biggest perfect square that goes into that is 100, and you would have 100 times 5, then take out square root of 100 is 10. You could get it that way as well. So both of these ways are valid ways to go from here to here. And then if you plug this into a calculator, you get approximately 22.36068. Round that off, let's say to the nearest tenth. The directions don't say, so just round off to a reasonable value here. This would be what m is, and it does say find RT. I want you to show me that you understood that x was the same as RT by writing that out there. So you'd have x is 22.4 meters, which is going to be the same as RT. QS, looking back at the picture, that was 2x, so we would do 2 times 22.4. If you do 22.4 though, you get 44.8. But if you go back to the approximation, so let me write out the whole approximation here. It was 22 point, and I'm going to 5 decimal places, 36068. If I multiply that instead by 2, that's going to give me a better answer. So that is approximately 44.72136. And so the best answer for this would be 44.7 meters. So be careful that you don't round off too much. If you're still calculating things, don't round off in the middle of the problem, or take a rounded answer, a vastly rounded answer to get another rounded answer. Always go back to, or just keep it in your calculator to figure out what the other things would be. So QS 44.7 would be the best to the nearest tenth approximation for that. And then example 3, let's take a look at that one. The area of this, which I'll write off to the side here, the area I am told is 871.06 miles, sorry, miles, not meters, miles squared. So a really big trapezoid here. We've got JM, or we're trying to find JM if KL is 36.2 miles, and we're also told that NL, which is the height of this trapezoid is just rotated 90 degrees from what you might normally see, but it's still a trapezoid, so that many miles for there. So I'm going to write out the formula in general. Get in that habit and we'll pay dividends big time. I'll write out the formula in general and then fill in what you know from there. So for A, that's this number, 871.06. For B1, that is, I'm going to call JM B1. I don't know what it is, so I'm just going to leave it as JM and solve for JM. B2, however, the second base, and the bases are always parallel to each other, so that's a good way to remember what your bases are. It's not always the top and the bottom. Whatever the way the trapezoid is oriented, you have to think of those parallel parts being your bases. This would be 36.2. And then from there, divide by 2 and multiply by the height, which we know is 19.4. So from here, how can we solve this? Well, we could multiply this 19.4 through to everything, but I think it's easier just to divide the whole thing by 19.4. If we do that, this will cancel with this, and that will be a lot easier to deal with. So we've got 44.9 is equal to JM plus 36.2 divided by 2. How can we get rid of the divided by 2? multiply both sides by 2. So I'm going to do that next. That will cancel that out. And then I'm left with 89.8 equals JM plus 36.2. And then from there, hopefully it's clear that you should subtract 36.2 from both sides to get what JM is from there. So this would cancel with this. And you'd be left with JM is equal to 53.6. And units are miles. Are they miles squared? No, because JM is just a length. It's one of the bases. It's not an area. So JM is 53.6 miles. Hope you found that helpful. If you're one of my students, email me with questions. If you're watching on YouTube and you're not one of my students, feel free to comment and I'll try to get back to you. But hope you're having a great day today. And again, hope you found this helpful. I'll see you later.